All right, so the next factoring technique that we're going to take a look at here is something called factoring by grouping. It's kind of along the same lines of factoring by a greatest common factor, but the greatest common, or sorry, yeah, the GCF, the greatest common factor. But the common factor here is going to look a little bit weird. So obviously the objective here is to be able to factor polynomials by what we call grouping, okay? And like I said, it follows along the same thought process as factoring out a greatest common factor. We know that from all of our factoring up until this point that the greatest common factor between 3x squared and 15x is going to be 3x. That's because I can divide a 3x into both of these. What we don't do is we rewrite, what we can do and we don't is rewrite these two terms with that greatest common factor. In other words, the greatest common factor is 3x. I could rewrite that first term as x times 3x. And then I could rewrite the second term as 5 times 3x. And then what we do is we factor out this common factor. That's why the 3x comes out front. And when we pull the 3x out of here, we're left with an x here and a minus 5 here. And so 3x times x minus 5 is what we get. That's not how we talk about greatest common factor. But that's basically what we're doing. And seeing it like this will help us in just a minute. The greatest common factor for this this other binomial over here is going to be negative 4y squared, right? Because I could rewrite this as negative 4y squared times something, and I can rewrite this as negative 4y squared times something. And I don't want to make the GCF confusing at all. But again, I think it helps if we see it like this as far as what we're going to do in just a second. So if I rewrite this term into negative 4y squared times what? 3y squared, right? That will give me negative 12y to the fourth. Then this other guy I can, again, rewrite as negative 4y squared, and this is going to be kind of weird, times 8. Well, it would actually be like this. Well, anyway, bear with me for a second. Right, so now I'm going to factor out this negative 4y squared. And when I pull that out, I'm left with the 3y squared here and a positive 8 back here. So that's how you would factor out a GCF. And again, it's not how we've done it in the past. And I don't want to confuse greatest common factor, but I wanted to show you this because it helps us when we take a look at a situation where sometimes the greatest common factor is not just a number or variable. It's an actual binomial. For example, I've got 3y times x plus 1 right here, and I've got 2 times x plus 1 right here. The quantity, x plus 1, is a common factor for both of those parts, right? This part and this part. They're both being multiplied by x plus 1, which is a factor. I can then factor out the x plus 1 and pull it out front. And so the x plus 1 would come out here. And then what I'm left with is what would be the other factor, which would be if I pull an x plus 1 off of here, I'm left with 3y. If I pull an x plus 1 off of here, I'm left with the 2. So 3y plus 2. That's the mathematical reason for why we get to do what we do. The quick, short, and easy way of doing this is if you get a situation where you have two parentheses, so two factors that are the same binomial, like this 2x minus 5, this 2x minus 5, then our factors will become whatever's inside the parentheses times whatever's outside the parentheses. And that's us factoring out the 2x minus 5. Okay? That's what we're going to talk about when we start talking about factoring by grouping. All right, let's take a look at some problems here. All right, where does the grouping come into play? Well, if you're taking a look at something like this, which is a 4-term polynomial, right? Everything that we've been factoring so far have been trinomials or binomials. Here is a 4-term polynomial and we want to try to factor it still. Well, what we can do, number one, we're going to want to write our terms in the correct order. So from highest exponent to lowest exponent, which this one is 3, 2, 1, 0. Right? Then I'm going to group. The reason why this is called factoring by grouping is I'm going to group the first two terms and then the second two terms. And this sign will always go in that second set of parentheses. Okay? And now I'm going to factor out a greatest common factor from just the parentheses. So now I'm going to focus on just these two guys. And they do have a greatest common factor, which is x squared. So I'm going to factor out an x squared. And when I do, we get x minus 2. Here, I'm going to factor out a greatest common factor of positive 9. I'm taking that sign with the 9. When we do, we get x minus 2. And look, these parentheses are exactly the same. That means we have another common factor that we can factor out. And so we factor this down into whatever's inside the parentheses times whatever's outside the parentheses. And those become our two factors. Okay? Of course, we would want to go inside these parentheses and see if we could factor, right? We've got two terms. We can square root either term, but it's not a difference, so we can't keep factoring there. Okay? So we're done factoring this guy. So we're grouping, right? Let's try again. We have 4 terms. I'm going to write them in order, and then I'm going to group the first two terms and then the second two terms together. Again, always taking this sign with that second set of parentheses. Now just look inside the parentheses. I have a common factor here of x squared. When I factor out an x squared, I'm left with x minus 3. Then here, I'm going to factor out a negative 5. I want to make sure I take that negative with that first term. And when I factor that out, I get x minus 3 again. And look, these parentheses are the same. So we're going to factor out that common factor of x minus 3. And then the other factor is going to be x squared minus 5. And then again, I would look inside this set of parentheses to see if I could factor it again. Because it is two terms, it is a difference, but you can't square root 5 and get a nice whole number, so it's not a difference of 2 squares. So I'm not going to be able to factor this guy down anymore. Okay, so we're done. Okay. I'm going to walk through one more with you and then let you try one. So 4 terms here. Okay, they're written in order, so I'm going to group this first two and then group these second two together. Now do a GCF for each set. GCF here is going to be x squared, and I'm going to be left with 3x minus 2 when I divide out an x squared from both of those. And then I'm going to factor out a positive 3 here. That's the GCF here. It's positive 3. And when I do that, we get 3x minus 2. And look, the parentheses are the same. So my factors become whatever's inside the parentheses times whatever's outside the parentheses. I would check this set of parentheses again because it's 2 terms, and I see an x squared, but they're not a difference, so we can't factor that guy down anymore. Okay? Does that make sense? All right, I'm going to let you try this one. Try this one. Group your first 2 terms, then group your last 2 terms, and then go factor out a greatest common factor. And then see if you have the same parentheses. Okay? Stop the video, give it a shot, and then you can start it back up and check your work. Okay. So group here and group here. Your greatest common factor here should have been a negative 2x squared. If you divide these by negative 2x squared, you should be at x plus 2. If I divide negative 4 by negative 2, we get positive 2. And then over here, I'm going to factor out a positive 3. Divide each of these by 3, and you get x plus 2 again. And we have our same parentheses here. So our factors become whatever is inside of the parentheses times whatever is outside the parentheses. And there we go. Okay? All right. Show you a couple more. Okay. Another 4 term where the exponents are all written in order, so we're going to group. Factor by grouping because we group. First two, last two. Now let's factor out our greatest common factor. And in here it's going to be x squared. So if I divide both of those by x squared, we get 2x minus 5. And then over here I factor out a negative 9, I believe. Negative 18 divided by negative 9 is 2. 45 divided by negative 9 is negative 5. And so we see that we have the same set of parentheses here. So our factors become whatever is inside the parentheses times whatever is outside the parentheses. I want to do a quick check. Okay, I have an x squared term here, so I want to check this guy. It's 2 terms. It is a minus, so it's a difference of 2 terms, and we can square root each of those. So it is a difference of 2 squares. We can actually factor that down. And so x squared minus 9 will factor into those 2 binomials where you square root the first term, which is going to be x. You square root the second term, which is going to be 3. And you do your plus or minus. Now we're done, because all of our factors are linear factors. So this was an example of when you could actually continue to factor. All right? Take a look at one more. Okay, and then we'll be good. All right. We've written our terms in order, so now we're going to group. Here, your GCF is x squared, so you factor out an x squared, where you're going to be left with x minus 2. Here, your GCF is negative 4, where you're going to be left with x minus 2 again. Your parentheses are the same, so your factors become whatever is inside the parentheses and whatever is outside the parentheses. And if you look inside of here, you've got a difference of 2 squares again. It's a difference, it's 2 terms, you can square root both of them. So the square root of x squared is x, the square root of 4 is 2, and then we're going to plus or minus, so our smiles add to 0. Okay, so we could have continued to factor here. All right? Hopefully that makes enough sense. That's really all there is to it. It is a little bit of a weird concept, but so try your homework and then come in and get some help if it's not making any sense.